Hey everybody, this is Larry. This is me going over day 19 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, which is the K inverse pairs away poem. As you know, anytime I do a really long video, for whatever reason, I usually have a summary in the beginning so that you don't have to sit through all this discovery and the delivery or whatever. And I'm gonna go over today's solution first, and you can watch me solve it live during just during this. And I recommend watching it if you want to get a sense of it, because because even though it's an hour and actually I have a lot of off by ones, I think my thought process is kind of maybe interesting for those who are interested in those things because I kind of break it down step by step, how I got to the answer, even though each step took longer than it should, to be frank, mostly because of off by ones, which you can kind of see in the video. I leave everything in the video, so it's not like, you can see it for yourself. I'm not gonna sugarcoat anything, or I can't because you can just watch it, and it's fine. But yeah. So I am gonna give a summary of my approaches. First is just and I don't really have to code up, so you just watch it. Fast forward and watch that. But basically, the first thing that I did was I actually was trying to figure out a pattern by brute forcing for small n's. And even though that I looked at the constraints and n times k, I was like, okay, I have to do an n times k algorithm because anything slower is going to be too slow probably. Like if you want to do n times k times n or something like that, that's too slow. Or these, like that's not going to be the solution anyway. Even if it passes for whatever reason, it might not be good for learning. So I knew that it was going to be n times k for this problem. But I implemented a brute force way, and you could kind of see me kind of do it using iter_tools.permutation, and just to kind of get a sense, get a feel about the patterns. Sometimes you're able to get a pattern directly, especially if you have done a lot of problems, then that's fine and that's good. The second thing that I think I mentioned that's of note, and you can watch this live anyway, I'm just saying it as a summary in case you don't want to, because it's a long video, I'm not gonna lie. And if you do watch it to the end, mad props to you. But even if you're on 2x, because I think a lot of it doesn't have to be watching in real time. Maybe watching in the background or something. I don't know. But in any case, the other thing I said was that the one thing about doing brute force is, and this is kind of cheating, probably a lot cheating, and you can't do it in an interview, but on maybe some kind of competitive thing, you can OGIS, which is Online Encyclopedia of Integer. I forget what the S stands for off my head, but you could Google OGIS and then a sequence, and it will give you sometimes the formula. It just does a search on integer sequences. Oh, I guess the S is the sequence. And it'll give you, an answer, and you can maybe implement it. Sometimes it's right, sometimes it's wrong, but that's just to give you at least a hint, if nothing else. But obviously that's cheating, but I'm just saying that that's what people do sometimes for learning anyway. And after doing that, to be honest, I didn't really discover anything. So then the second thing that I said, I kind of noticed the pattern, but I actually got the wrong pattern from that. But yeah, and actually now that I think back to it, there is a pattern that I could have noticed if I was really astute, but I didn't because it's a hard problem to notice, or hard pattern to notice maybe. And then the second thing I did eventually, I was like, okay, let's, I knew the n cube solution, so let's just do the n cube solution, write it out, because sometimes if you practice long enough or practice hard enough, you're able to skip. Like you're able to make optimizations and reduce things from say n cubed to n squared. Like, oh yeah, so you have this formula that's n cubed, but you can actually do this in n squared because of certain things. Sometimes you're not able to do it without writing it out and noticing the patterns, because before I wrote it out, I think I had a different formula in my head. But once I wrote it out, I'm like, oh, actually, this formula is not quite what I had in mind. It's this other formula. And then from that, I was able to get the answer. And anyway, but this is the n cubed formula, which is here. And I do actually make some observations here. But basically the idea is, okay, so you have a sequence of A, B, C, D of length. I think on here I have D for the length that we have already placed. But actually that's very confusing. Let's just make it E. But yeah, but D is basically, D is number of numbers we already placed. And basically the idea is that, okay, now you have a sequence and they could be in any order. So in here there are 5 numbers, or it could be any of the 5 factorial numbers, right? Or permutations. And the thing is that now you're putting in a new number F, inserting F. So then what does that mean? Because F is the largest number that you're inserting, there are only a couple of possibilities, right? Which means that if we insert F here, let's just say here, for exclamation mark for insert, that way we insert. If we're inserting at the end, then the K values does not go down because there's no inversion. If we insert it here, well, there's one inversion because F is bigger than one number by definition, no matter what that number is, because F is the largest number, right? And then what if we insert it here? Well, now K is -2 because now there are 2 inversions, right? Because F is greater than D, F is greater than Y, no matter what those numbers are, right? And then so forth. So that's kind of the idea behind this loop. Hope that makes sense. But yeah, but that's basically the idea here, is that D is the numbers we already have in the sequence. And that's just equal to the number we have left to put in, and then the beginning number or beginning n, and then we just sum it up all that, right? Hope this formula makes sense. The problem with this formula, of course, is that, and I use LRU cache because I talk about this in the video later. Basically what I was saying is that I'm just doing this as a prototype because I know that it wasn't going to be fast enough, and it's easy to see why. Left is equal to 0 to n, and K is equal to 0 to n, and this one has O of yeah. Well, let me explain it a little bit better. So then that means that the n squared number of possible inputs, and for each input we do O of n work because of this for loop, right? Roughly speaking. So that means that this is an O of n cube algorithm. Oops. And obviously n cubed for n is equal to 1,000 is going to be too slow. But like I said, so I was just prototyping to see if this is correct, and luck is, you know, in a very good way, this was correct. And I also, to be frank, used a little bit cheating, not really cheating, but of course, if you're in a contest, you don't get, you know, like what I did was I just ran it for a big case just to kind of see if this code worked, and this code did work. I hope so. Well, I mean, it did. Oh, whoops. So I rewrote this one for teaching reasons, but I left that in. Whoops. But yeah, but. Why am I so sloppy even on the teaching? But in any case, yeah, so the cheating that I did here was I did a random input and I got an answer, and I knew that this was correct because they give you the correct solution, right? So then I knew that I have a solution that's correct but n cube. So you can also just, you know, play around and put in n is equal to 1,000 just to you know, just in case that it works, because for some reason that you don't know. But in any case, it is going to be given a time limit exceeded. But so that's basically the idea here, is that, okay, now I have a formula that's right, but it's not fast enough. So I had to dig back into my toolbox to kind of think, okay, how do I get this from n cubed to get it down to n squared? And I don't think I could get it down to below n squared just from the nature of this thing, unless there's a closed form formula, which you know, given mod and big int, maybe a little bit messy anyway, but in theory, if there's a closed form, then maybe you could get to O of n, but I'm not good enough in math, and it's very hard to kind of find those closed form formulas unless you either know it or or you Googled for it, which is not what I did. So but yeah, so basically you have this thing. So then the thing is to notice is that as someone who actually is kind of funny, because I feel like we've been doing a lot of prefix sum. Literally the last two, now that I think about it, the last couple of days in the daily contest were there had some prefix sums. So yeah. So the idea here is just prefix sum, which is that okay. The thing that I noticed is that okay, this loop, if you write it out, it's just total is equal to count left minus one, k plus count of left minus one, k minus one, dot dot dot, which is obvious, all the way to plus count of left minus 1 k minus d. And I always spoiled it a little bit, which is prefix sum. And you could kind of see that the sum, if we have prefix, some function is equal to left of k, then that would get us the answer. Because now, let's just say, this is equal to, like the prefix sum ideas. And I'll go over it in a second, actually. But that's basically the idea of, okay, now I have the prefix sum idea. Let's convert this to bottoms up. And I did convert this to bottoms up, but I got really confused at some point, and you can see this in the video. Like I said, I'm not hiding anything. The thing that I got confused about the video, in the video, is that I was like, oh, actually, k doesn't have to go up to n. K can goes up to n squared, and choose 2, because, for example, if the input is 5, k could actually be, 20 or something like that, right? Because there are a lot of inverse pairs, because the n squared, O of n squared number of inversions, right? The maximum inversions. So then I was like, oh, in that case, that would be n to the 4th. And then I just confused myself there for way too long, to be honest. But I eventually recovered by saying, oh, wait, no. I mean, yes, that is the maximum number of possible inputs, but there was an additional constraint, which is that k is equal to the min of n square, or to 1,000, right? So once you notice that, or once I noticed that, I was like, oh, this solution still works. So then now let's go back to what I did, which I have here. Oops. So then now I just take advantage of prefix sum. I talk about prefix sum in some of my previous videos. So I think I think I definitely talked about it yesterday, but very briefly, the idea about prefix sum, and we needed it here, is that, let's see. So now we have, I'm just going to write P for short. P of ij is equal to P of I j minus 1 plus some other number, which is dp of ij in this case. So then, and what does this mean, right? This means that if you expand it out, then p of ij is equal to dp of I j minus 1 plus dp of ij plus p of I j minus 2, right? So, this is just expanded out. I hope this makes sense. And dot dot dot. So p of ij is just equal to p of dp of I 0 plus dp of I 1 plus dp of I 2 plus dot 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 plus dp of ij, right? So that's basically the idea about prefix sum. And the second thing is, so that's basically the idea about the prefix sum. You can kind of see me, so I have this code, right? I translate this directly into bottoms up, so hopefully that part is illustrative as well. Though, like I said, I confused a little bit about the k, because I forgot about, or I didn't forget, I just kind of confused myself a little bit. I forgot that k is, less than 1,000. So once I fixed that, once I fixed that, everything became way more straightforward, except for I had an off by one again. I had a couple of off by ones, to be honest. So you can watch that. But the idea is okay. But you know, the tricky thing is that there was a for loop here, and before I reduce this to, before I had this thing, which let's comment down for now, I had this for loop. I have essentially this for loop, right? And I did actually have this for loop if you watch it. So yeah, this is current K. Oops. And I also have a thing here. But so if you look at my bottoms up, and you could find that part of the video. If you look at the bottoms up, you will actually see this video, this code, and of course, again, this is n cube, which is too slow. But I just kind of wrote it word from word, and you can watch me do this and then verify that this has the correct answer. This is technically dp of left current K, but I mean, that's assuming this is right, give or take, right? So I just confirm first that it has the correct answer before I optimize it, because if you're optimizing an incorrect formula, that's a recipe for disaster. And the thing is, then I did actually run into an off by one, so I actually spent a lot of time here before I did the optimization. And then once I did figure out my off by ones and finally got it correct, and that took a while, then I optimized this by, okay, thing to know here is that, thing to know about this formula is that we actually sum up dp of left of current K is not equal to this prefix sum, is equals to left of minus 1 current K minus, or just, yeah, minus, well, this, plus this minus 1 plus this minus 2 and so forth, right? Dot dot dot. But not dot dot dotting to the very end is dp of current minus 1. This is not 0, or it's not always 0. It depends on what this offset is. So it's actually current K minus offset, right? Or sorry, minus the max offset, and the max offset is D. So this is the formula that we're doing. Let's just add some colors onto it. So that's what this translates to, right? And then now this is where the prefix sum comes in, because the way that right, and if I written this out, this would actually be way more obvious, but I was very sloppy. But yeah, so now, well, what is this thing too, right? Well, prefix sum of left minus 1 current K is equal to, or this thing, plus dot 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 plus, let's just do plus dp of current minus 1 current K minus D minus 1 plus dot 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 plus current minus 1 0, right? So that's this is a basic definition of prefix sum that we already defined, so I'm not going to go over it that deeply. Hopefully this makes sense. But that's not the solution we're looking for. We're looking for this one, right? And this is where the I always find it a little bit tricky, but then now you have current K minus D minus 1 is equal to just this chunk, right? And of course, and this is really bad notation for visualizing the lining up, but you can see that now if we have this and we have this, then it is just this. So this minus this, and of course in that case all this stuff cancels out. This part is just prefix this part, it is just this part, and that cancels out, right? And that's what we want. So then that means that this is equal to this formula, that's the idea about that part of the prefix sum. And then all that left to do is just implement it. I had an off by 1 because, like I said, I was sloppy. And I was rushing it at this point because I knew that this was the right solution. And of course, this can be 0 because it depends on what D is. So I just have to make sure that we don't go out of bounds. But after that, that is the solution. And then after we finish a row, we calculate the prefix sum. So that's basically what I did here. We finished the row and then we calculate the prefix sum for all these values. And this formula, again, is just this formula, right? Which is this formula, which you can show to be correct. Let's kind of see the entire screen here again. Yeah. So that's basically the idea. That's basically the solution. Even the explanation took me about 20 minutes. So hopefully this is a really illustrative, because I try to really slow down my thought process so that you can kind of see it step at a step at a time. And okay, and then now, just talking about the complexity, right? The complexity, of course, the time you can kind of see. Maybe I don't need to write it out. You have a for loop from n, and you have a for loop to k, and a second for loop to k, but it's not an inner loop. So this is going to be n times k. This is n times k time, and in terms of space, it's a lot easier, right? Because you can see it here and here. That is just n times k space, O of n times k space, and O of n times k time. Okay. One more thing, which I haven't done. As a homework, as an exercise, as an upsolve. Okay, you can actually, the key thing to notice about this is that dp of left only depends on the row left of -1, right? So, and the prefix as well. So because of that, well, the prefix actually only looks at the current row, but anyway, because of that, you can actually reduce this to O of k space, or O of k space. So as an upsolve, try to reduce this to O of k space. I have a video somewhere talking about how to do that exactly. Look that up, and I think I call it the dynamic programming progression. Just find it on YouTube, or someone will post it on the link below. And yeah, and kind of fill it out that way. And so even after you get it here, do the optimizations to get it to O of k space, and that'll be linear space in this case, because k is at most n. Well, I mean, k technically could be bigger than n, but in this case, it's constrained by O of n, roughly, you could say, maybe. But either way, it's O of k space, and that's more effective. And just to kind of give a very 30-second explanation of the space efficiency, is that, let's say you're throwing out the array, you have some numbers A, B, C, D, E, F, G, and then the next, in this for loop, you go to the next row and you'll throw up, okay, let's do another one, H, I, J, K, L, M, N, and of course this number depends on these numbers, this one depends on these numbers, and so forth. So then next time you do another row, you go, okay, O, P, man, I'm gonna mess up the alphabet and you're gonna laugh at me. L, M, N, O, P, Q, R, S, T, U. I'm singing the song really terribly too, right? But anyway. So you're filling out this row. The thing to notice is, as we said, this row, this number, whatever it is, only depends on the previous row, right? And all these numbers only depend on the previous row. And what that means is that all these numbers that happened before, and in this case, as you keep on filling out, you're gonna have more and more and more and more. Here, you can ignore all these numbers, right? And because you can ignore them, you can actually get rid of them. And that's the idea is about saving space, is that because you don't need those rows, you can get rid of them. And you don't have to keep track of them. So, and there are different ways of implementing that, say, but that's basically the idea about getting that to O of k space. And that's all I have for this video. Hopefully this is very long, even knowing the answer is very long to explain, but fortunately for you, maybe today is a Saturday. Happy Saturday. So I am doing it very slowly to do all the explanation, But I also spent an hour just explaining or me solving this problem because I ran into a lot of silly issues, even when I did have all the tools, right? So if there's a couple of lessons here, is that even maybe I'm arrogant. Maybe you're saying no, this proves that you're not good. But anyway, I'm making this statement. You could start your own YouTube channel for whatever reason. But I consider myself pretty good at this, and I had all the tools. Like there was nothing that I didn't know how to do. Because for example, the prefix sum, maybe you have the idea, but you didn't know how to do it quite exactly. Like getting from this loop to prefix sum does take exercises, and I knew how to do it pretty quickly, but it still took me an hour. So sometimes in these things and in life, it's just about the grind. And on good days, you'll get it quickly. And on bad days, clearly you don't get it as quickly. But if you believe in yourself and you keep grinding and you pace yourself, you could get there. And sometimes, especially when I'm starting out, or when I was starting out, it would take me days to solve these. And I have to take breaks and come back later. So I do other things, like go to class or something in between, but I still come back later. And maybe one of the good things about growing up when I did was that I could not just Google for the answers, because Google did not give you the answer. No one solved these problems before, or not no one, but no one did it and then post about it. So that's what I wanted to give. That's one of the things that I want to give back. But that said, that kind of persistence, that kind of grinding, I would literally spend days on a problem, especially the harder ones, obviously. Well, I'm hopefully not spending days on the easier ones, but in the beginning, that's what I did as well. And this is becoming a little bit of a lecture. I don't even know if you're going to watch to this point, but if you are watching right now, leave a comment so I could give you some love. Thanks for the support. I always appreciate it. This is a long video, and I sometimes don't know if it's worth my time, to be honest, because this is really long, and you can watch a 5-minute video of someone just explaining the solution, and you're like, okay, oh, this makes sense, and pretend you understand it. But I really want to go over the thought process and the step-by-step and everything that goes with it, and also just for you to see how even someone who's quote-unquote good can struggle. I mean, there are definitely people better than me, but I'm still good. It's just that people are really good, and they are so good that they were able to do this immediately, and more props to them. But I'm hopefully hopefully this gives you that as well, is that given that I can sometimes take an hour to do a problem that you look at this code, it's about 20 lines of code, and you're like, oh, this is easy, this is 20 lines of code, and it's like, well, and of course you could even clean it up to have fewer lines of code, but you get my point. Well, this took a lot of effort. Even if I knew how to do it, it took a lot of effort, right? So I wanted to show everything for that reason. Yeah, these things are hard. Keep on going, keep on grinding. That's my message for the day. Even though it's left at 20 something minutes, but that's still my message. So hopefully, stay in there. And I know that it sounds like spam because everyone does it, but come to my Discord channel. We could discuss the problems, and and I do most of the time. Or I try. And there are other people who are like mine at this point. Like we have a couple of thousands people, and a couple of people very friendly and go over it. So I definitely appreciate that kind of community, and it makes me feel good, to be honest. And I'm a little bit on the rant now. It makes me happy to kind of help people do it, and people, I don't make money off this. Everything I get, I donate to charity. But what does make me feel good and keeps me doing this is that every once in a while I get a message from a longtime viewer / Discord person, and they're like, oh, I got a job at this place, and thanks a lot. And usually it's a journey that we've spent months on. This is no there's no, oh, I watched one video from Larry and it's and I became whatever. I wouldn't even believe you if you told me that, right? So it's kind of rewarding in that way. In any case, I don't know why I'm ranting today. Maybe it's Saturday, like I said, and it's late. But anyway, my point there is it's tough. Keep going. Keep a deliberate pace. Don't burn yourself out doing these. It's not worth it. And you're not going to get anywhere anyway. Plan for a marathon, not a sprint. And with people helping you out along the way. That's all I have for now, for today. It may not be what you have for today. If you want to watch how I explained or how I solved this problem later on, because like I said, that's a struggle. It took me an hour or something, I don't know, but something around an hour. So hopefully you get something of this. Hit the like button, hit the subscribe button. Like I said, join me on Discord, give me some love, and you could watch me solve it live next. It is a little bit awkward because I do the intro again. Like I said, you could see my entire thing live, including my initial reaction, including the intro. So, okay, that's all I have. I'll see you later, and stay good. Hey, everybody, this is Larry. This is June 19th of the 2021, but also the 19th day of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, chat about this problem, other problems, whatever you like. And today's problem is K inverse pairs array. I haven't even looked through this problem yet, but I just noticed the mod 10.9 mod thing, and I always, as you know, have this mod song of mod, because I always forget otherwise. And might still forget it. We'll see. But yeah, I usually solve these live, so if it's a little bit slow, let me know, and then I will ignore it. So because you can fast forward for it, it's fine. It's live. I'm going as fast as I can, and while still explaining the problem. But usually, but sometimes I don't, succeed in that. But anyway, for today's problem, K inverse pairs array for an integer array's nums. Still have some allergies this part of the year. I don't know why. It's June, but like about to sneeze half the time. But in either case, okay. I is less than j, where j I is greater than or equal to j. Given two integers n and k. Okay, so inverse pair is a pair of integers I of j, where so they're in order, but nums is I is greater than j. And n and k, I mean, I suspect this is, so it's probably just from experience. I actually don't know how, whatever, but I don't know the answer quite yet. But just from experience, is probably my guess is going to be dynamic programming, and it's probably going to be something that's n times k, because any slower, and it's not going to be fast enough. So that's like a hack from looking at the constraints. So there's you need to control your complexity for that. So n times k is probably fast enough, or n squared if you want to call it that. So there are a couple of ways to think about it. Right. And I'm just going through all this, not all of them, but a couple of scenarios in my head. One is, okay, one at a time. If I look at, if I start at one, oops. Let's say if I start one and then I insert two, there's two ways to insert two, there's three ways to insert three, and so forth, dot, dot, dot. Of course, that's going to be n factorial, even if you do some crazy caching. So that's not going to cut it, but I was thinking about what that would look like, and that would not be n times k times in either case. Another scenario would be to just look at, okay, or just thinking about like, okay, one digit at a time. Okay, let's say the first digit is, I don't know, 5, and then the second is 3, and then and then what would that look like, right? I'm just kind of feeling them out in my head, and I don't know. Yeah. I don't really have a good idea right now, but those are the things that I'm thinking about just to localize it. So 0, it's gonna be 1, 2, 3, 1. So it's gonna be one swap away from this. And 2 is gonna. Is there a 2 answer? I don't think there's a 2 answer, right? Like n is equal to 3 and k is equal to 2. Because by definition, a 2 answer means like there's no possible 2 answers. And during a contest you can do this, but but we're not doing a contest, so I'm still exploring the problem. But I suspect this should give you 0. So I'm just doing it for I'm doing for going through my process reasons and just to visualize it. But 2 should be 0, right? Oh no. 2. Exactly. But if it's 3, 2, 1, then you have. Did I miss a scenario? Oh, I guess 2, 3, 1 is a 2 answer. Okay, so I was wrong on that one. But so another thing that you can do, which I'm getting a feel for, which is a little bit unfortunate, well, maybe not unfortunate, is just brute force on small examples, right? And here you can clearly see, well, maybe not clearly, but you notice that what is 3k equals 0, 3k equals 1, 3k is equal to 2, and this is by literally manual enumeration, and you have this, right? And then what does that mean? Well, this just looks very familiar, which is based off if n is equal to 2, then what is the answer, right? For 0 there's 1, and then this is 1, and then now you have this thing, and when 1 is 1, then you have just 1. What does that mean? Is this a pattern? Dun, dun, dun. I don't know. Is the next number gonna be like 1? So I don't So I don't know that I can generalize pattern of like 3 things. So what I'm gonna do is what was I gonna say? Is brute force for small n's, just so that I can kind of see a pattern. It might not be enough. Sometimes it's not for complicated things, but why not? Let me see. Is the next permutation in Python? I always, because that doesn't come up that often. I always forget. I mean, I think the answer is no, because if there is, then it too does have permutations. I feel like I feel like I'm wrong on that one then. Okay. So yeah. So let's write a brute force thing, which is n factorial, but of course we're only doing it for small n's, and then kind of see how we feel, or how it looks, just to get a texture on the problem. So okay. So how are we running a brute force? Let's just see. Oops. For a permutation array and this, I think that works. Let's just kind of run it real quick. Okay, so that looks like it works. We don't need to run it like whatever times, but let's just do it for 4, 5, and 6. And then now we look at the permutation array and then just count the number of inversions. which is what this one wants. So, and we could do it naively, it's fine. J is less than. Wait, is that right? That is not right? Because this can actually go beyond n, because it can be n choose 2, right? Because yeah, because with the strings everything is in reverse. Yeah, whoops. I think that may be a flaw in my logic, but in either case, we still can do the brute force. It's just now the pattern might be more interesting. Let's give it a spin. I would also say that I'm just generally not good at these kind of pattern things, so it is what it is. Oh, I was wrong about the one. Why did I say it was 1, 2, 2? So 1, 1 is 3. Did I miss something? What? Oh no, I'm looking at the 4. Okay. So for 0 is 1, yeah, 1, 2, 2, 1, that's fine. Okay, let's actually print out items. Let's sort it. And this is just to kind of get a user visualization. So it's 1, 2, 2, 1. We have 1, 3, 5, 6, 5, 3, 1. So you can see that this is symmetric, which is not that surprising because you can just inverse the array to, yeah, you can use the inverse array to calculate the inverse solution and then do it again. So then the question is, what is this formula that you can see, right? Yeah, and it looks pretty basic in. Is that true? No, I was gonna say it looks pretty straightforward until the last number. How do you? Oh, well, I have to figure out this formula, but it is a little bit tricky. But naively, it looks like that. You know, this is equal to this, and so forth. For me, this is just to get a sort of intuition, because there are only a couple of ways that we can go from here, but it's not clear to me because I'm not good enough in combinatorics, to be frank. I mean, you could see that this plus this is equal to this, but it falls apart here, right? Well, this loops back, and so it adds 19, but how? Why? Dun dun dun. And then 11, also how? Why? 19, 11. And for example, like 6, how do you get this 6? Dun dun dun. But the other parts seems reasonable. Like 22 goes to 71, but then now going this way. Now how do you get the 90 and the 101? Here you have 5. Oh, no. 6 plus 9 is 15, which is fine. But then now you're missing 2 numbers. So we have to figure out how to generate 2 numbers per sequence. At least, maybe. If you only need 1, then it would be easier because You just take the summation, but like almost like a prefix sum and then subtract the delta of it. Like getting two of them it's a little bit tricky. Because here the only new number is 22, which we use here, but I don't know how to get the 19. So this is not super. I suspect it's something with the relationship of. Dun, dun, dun. Also note that this is this goes up to 15 for just 6, right? So that is that n choose 2? Yeah, that's n choose 2, or 6 times 5 over 2. So this is going to grow quadratically. Trying to think about the relationship of, is there a property that is true between k inverse pairs array? Let's say k is 1. What does that mean? Is there something more fundamental? That means that, okay, given a k is equal to 0, you move one of the things, so it's gonna add whatever, right? And then for how do you look at these two cells? Like, what is the relationship here that let us get to here? Ignoring stuff like that. This means that, so that means that okay, so the relationship is you have a previous number and then you add it to basically the idea is that you haven't changed and you want to change it, right? I'm not sold on the way that I said it. Because, okay, so this is 3, 2, 3, 2 is equal. So 4 with 2 inversions is just equal to 4 with 1 inversion. I mean, 4 with 2 inversion is just the same as this, which makes sense because that's just like adding the biggest number at the end. Or if you have the biggest number, you with 1 inversion and you put it on top of the one at. I guess I could see that one. Basically, the idea is that, okay, so you have some sequence and you have the biggest number, and you want to create one additional inversion. That means that you would have the biggest number. You either put it at the end of the array, or you put it at the second to the end of the array to create one inversion. And by default, by definition, you're gonna have all those things because you're creating one inversion that way. Okay. But what if you want to put it anywhere else? I guess that's the question, right? I don't know if that explanation makes sense. But okay, so now let's say I have 3. I have 3 inversions. I can either, yeah, I mean, I don't know about how much of it I'm just fitting the numbers in, and I don't even know if that makes sense for 5 times 15, we have to 20. And also then how do you explain how do you get to 5, right? 22. I don't know if I know this one. But sometimes programming is just grinding out the reasoning. And this is symmetric, so I don't really need to know the second half. Let's just do one more. I think we're at the limit of what computers can do. Maybe not 7, but after that it gets, like I said, murky. One thing you can also do if you're on an online contest and you're cheating, you can actually just go to OGIS to figure it out. Obviously, I'm not trying to do that here because that's just not interesting to me. Or like at that point, why are you doing it? Right? Like, are you learning anything? But this is also where it seems like it some logic is incorrect a little bit earlier. But yeah, if you go to OGIS and you can actually Google OGIS and maybe like the first few numbers of a sequence, and you can probably figure that out. But yeah, I'm still trying to, I can't get around the idea of, while we're having an array, we insert now we have the biggest number and we sort it one at a time. But I mean, I could do that, but it does have a for loop component. So it's going to be n cubed as a result. I think that's why I mean, that solution would be interesting. But I mean, okay. In the interest of trying to see whether we have a solution, let's write an n cube solution and then figure out if it works first, and then we'll worry about it that much. So I'm not gonna lie. So this one, as I said, I don't know how to solve it. I'm really bad at combinatorics, so I'm gonna do some, like for solutions that I know the answer to, I try to explain it as best as I can. But this one, I'm not confident about, right? So you're gonna see me do a little bit more experimental and less about explanation because I don't know if they're gonna be right. But so let's play around with it. Let's also use our friend LRU cache for now. I'll probably end up doing another explanation that I put in the beginning of this video anyway. So yeah, so let's just go count, say. Let's just say we have an n and a k. Okay, how do we get n and a k, right? So this n is equal to the numbers left. So if n is equal to 0, we return 1. If k is equal to 0, we return 1. Otherwise, we return 0. Okay. And also, if k is less than 0, we return 0 because we went too far. And then now we go one at a time, right? So now we have the biggest number, we have a sequence, and we can put it anywhere we want. So let's start at the end. If it's at the end, then this is just n minus 1. You used up one number, and k didn't change. Plus, we used up one number, and then we put it in this second to last place. That means it's going to be k minus n. No, this is k minus 1. And then now you put in the second position, which means that it's bigger than 2 numbers, so it's k minus 2, right? Because now you've created 2 inversions. So then this is just sum of all these things. Of course, ... So let's actually implement this. So yeah, for Is that true? Because if that's true, oh, maybe that's how. Because the way that I put it is a little bit awkward, but we'll see. Right. For offset, say, in range of n, does it go to n or n plus 1? N digits. What am I doing? I have to get my indexes right is what I'm doing. So this n is not the same n. N, this is how many digits that are left to be inputted. So the current number of digits is different. Okay. So this is left, let's just say. So that means that slots is equal to n minus length plus 1. Well, I guess slots is true, but yeah, let's just do D for delta. I don't know, that's yeah, okay. I might be off by 1 here, but yeah. And of course, this is not intentionally sloppy, but it is a little bit sloppy at, whoops. Well, maybe not this sloppy, but it's a little bit. I know that there are optimizations I can move. I'm just kind of trying to prove correctness now. Yeah, that's not good that even this is wrong though. Dun, dun, dun. So did I open off by 1? Yeah, I did. This should be D plus 1, but would actually imagine it to at least have. For k is equal to 0, I expect at least 1 as the answer. Whoops. Maybe not that sloppy, just a little sloppy. Okay, so at least we get that right. Let's just do some. Okay, so this is the right formula, as you can see. I did hesitate a long time before coming here because I knew that this wasn't going to be fast enough. Because if you have, say, 1,000, it's going to be too slow, right? And this is obviously a easy thing you can test. I know give you time limit exceeded, but you shouldn't even need to run it to let you know. But I'm the one recording a video, so I'm just kind of illustrating a little bit here. But the good thing is that you can see that this formula works, and I actually didn't know that formula anyway. But like I said, I kind of didn't really consider it as a result. Let's also double check for a second, because right now I chose the k that's on the other side. So let's just do 70. Okay, so it's still right, which is good. Just want to double check. The thing to note now that now there's a thing to note, right? Maybe I should have done this in the beginning, to be honest, and that's my fault. Because I think I had a different. Because sometimes okay. If you have enough experience, you can probably jump it. Like you're able to, because you've done this. What I've done already. I guess I've done it, but I'm just a lot of shape out practice. But what you can do is just skip ahead because and it looks magical because you're like, oh yeah, because I've already done it. But the thing is that what I should have done is just write it out, because I think one thing that happens is that I didn't, so I just mark it off. But now that where I'm going with it is that now that I've written it out, now I see where I'm going, right? which is, let's say this thing is what we said before. This is just total is equal to, like, and this is a comment so that I won't forget, left minus 1, k minus 0 plus dot dot dot, right? So you can, the thing to, and this is just from experience, the thing to notice is that this is essentially a prefix sum. And this gets us what we were, oh, I don't have the thing up anymore, where we were like looking at the thingy. And because of that this prefix sum, we should be able to reduce this a little bit. Right? What does that mean? I have like 80% of an idea, and I'm trying to figure out how to get it through the finishing line. I mean, basically you have a prefix sum, and the way you do is pre-calculating it. I'm trying. I don't know if I can do this easily as a tops down as a result, but you can think of it this way, right? I'm trying to figure out. I actually am trying to figure out how to do it tops down, but maybe I don't have the visualization for it. But the idea is that, okay, well, one is let's convert this to bottoms up, and then we can be able to do the prefix sum that way, right? Because then this is just an additional through this array, and to reduce this to O of 1, right? Because this is now O of n, obviously, but we want to get to O of 1. So if we have all the previous ones, we should be able to do it. Yeah. Okay, so I know that I'm not explaining super clear, but let's, bear with me for a second. So yeah, so let's just have a couple of arrays for a second. So let's just go dp because I'm lazy. It's equal to 0 times oh no, let's just say this may be not, I mean, this may be unnecessary for the problem, but it's fine, right? And in here, let's write it bottoms up just naively for now. We know that the state of 0, 0 is equal to 1, and then for left in range sub from 1 to n plus 1. For k variable names are hard. I'm literally spending minutes on this one. For current k, say, in range of, it can go from 0 to left. Is it left or left plus 1? I guess left plus 1, right? Because it could be left. And here we do okay, so we do 0 is equal to 0. Oh no, okay. Maybe this is a little bit off. So d is equal to n minus left, and then for offset in range of d plus 1, dp of left current k, we dp left -1 k minus current k minus offset, right? And that should be good. Again, this is not optimized, right? Oh, like I said, already forgotten the mod, and I would have, I mean, I would have chose a big number and then see that's wrong. Okay, so this is wrong. Whoops, did I miss something? Dun dun dun. Offset is this. Oh, I just have to check that if current k is greater than or equal to offset. Hope that's right. Oh, hope that's the only part. The reason is because there's negative things, and that's the one thing that I get annoyed about Python. Is that okay? Maybe that's not it, but because when you have negative indexes, it wraps around a little bit within reason, and that always messes me up because I rather it gives me an exception because that's not expected behavior for me. But anyway, do I have an off by one here somewhere? I get the other ones right, but let's okay. Let's get rid of these ones because they're useless. Now I'm trying to figure out what I'm doing wrong. So 1 2 1 0, huh? What am I doing wrong? Usually my translation is pretty okay, but clearly not. Dun dun dun. Grabbing off by 1. So you have a left and a current k. This is literally the same, right? I mean, clearly not, but huh. Dun dun dun. Additional challenge. Usually I have a lot of typos lately, so why is this wrong? Oh, just one of those days. It seems like I'm just an Oh, I know. So this current k thing is wrong as we had here because, like I said, k can be up to it can be n choose 2, right? So actually the number of k is way bigger than that. I keep on choosing n is less than k, or sorry, k is less than n, but technically k can be bigger than n, right? As we saw before, and so it's not accounting for all of these. So this should be actually on the left side. So this is so wow. So I don't even know if this is going to be fast enough, even if I do, because it is n squared on the inside. So I'm wrong on this one, actually, because like we said, wow, I'm just going through a lot of wrong paths today. Even if we had this thing, which it works, but it's going to be way too slow. It's not even n cubed, that's the problem. It's going to be n to the 4th, as I said. So for example, you could have 4 and 10, right? I don't know if 10 is too big, maybe. Okay, maybe n is too big, but we have 6 and 10. I think that would have been good. Yeah, 6 and 10 gives you a right answer. So for some reason, and maybe this is just practice, I thought that left could go from 0 to n, and k could go from 0 to left, or something like that, right? But actually, k could go from 0 to n, n choose 2, right? Is it n choose 2? But n times n minus 1 over 2. And in that case, that means that there are n cubed inputs to this, and that means that this is making Larry very sad boy right now, because that means that this is essentially The inside would be something like that, and here let's just say, roughly speaking. I mean, I'm hand wavy here, but it should work if too slowly. Okay, not even too slowly. Huh. Why do I have it wrong? Wow. Maybe the answer is like something really obvious and slow, but I'm just being, I mean, I guess this is the same thing, except for longer because that's zeros. So I'm off by something really silly. Yeah, I mean, it's fine. So for n is equal to 0, n is equal to 1 is y, n is equal to 2 as well. Why is that? I mean, the thing what I was going to do is that this is n to the 4th, and then I was going to optimize this loop away, but it's still going to be n to the n cubed state. So that is definitely way too much, unfortunately. But let me still I mean, I still want to get this right though, even if it's a little bit slow. Tell me why. But I don't know why this is wrong. I mean, this is very I'm doing a very poor example of bottoms up explanation, I suppose. Oh, I guess. I mean, this should be there, but did I have is the left one? So offset is 0. Yep. Maybe I was just lazy on this one. Maybe this should for smaller numbers. Let's try something like that for a second. Whoops. Is that right though? This number seems right. And that number seems right. I might... So maybe there's some weird things with the mod or whatever, but... Or maybe that this formula is just wrong. And it doesn't extend past 10. Why? Why is that? 3 goes to... so this should be... I mean, I thought that this would strictly be whatever, right? Like, why is that wrong? Very weird. Yeah, well. Very weird that we're wrong on the big numbers. But, So I am off by... So this part is just a chunk that's weird, but... But... And I've been sitting here for about 40 minutes. I don't know what's going on here. Well, this one is just too big. Oh, it's over mod, so maybe that is too big. It's just... But yeah, I mean... we have to figure this out, but that's fine. The idea that I was gonna say was that now I have this, and then you can do a loop through here, through all these, to get the answer for this, right? And then you could do them all in the same way by doing a prefix sum. Yeah. Wait, what is max k is equal to? Let's just do. I want to get it right, so let's just do. I don't know why this is. That's weird. Why is that wrong though? Because for 3, for example, it goes up to 6, right? For 1, it goes up to 0. Did I mess this one? It should be plus. Maybe that's why. Yeah, maybe. Oh, I know why. Because. Okay, I confused the left and N again. Hopefully I don't embarrass myself by saying that. Okay, well. Why? D is equal to N times left, so for left is equal to 1. Well, now this is a little bit awkward then. I don't know how to get this bound, but in any case, if my original analysis was right, this would have been the way to go. But alas, it is not. And I don't know why this is wrong though, but It still should be right. I don't know why this is so wrong. Why? Am I just being that dumb today? I wanna know what are my inputs? For 3 0. For 1 it goes 1 0 1 1, that's good. 2 3, that's good. 4 it goes up to 6, that's right. So why is this wrong? For 3 it goes up to 6, right? Anything bigger than that is just 0. So then why is this now I can find the problem. How can this be wrong? Okay, so was I just... No, I mean, I got this fixed, but still off by something. I don't know why. Like, if I add this to 100, would that work? That worked for up to whatever, but... It's very weird. Why do I have an off by 100 variable? Am I doing something funky? So the thing that I'm worried about now isn't that, it's just about the smell. And having some weird constant means that, and that you don't understand, is a code smell. And I am trying to figure that out. Does it work with 25 or 100? Yeah. Huh. Oh, what? It's not we choose 2. It is literally then. Okay. The divided by 2 thing is the weird thing. Maybe not. Not enough of a weird thing. I don't know. And I'm just like hacking it together, but I don't. Is left plus 1 square because I don't get it. So 3 should go up to 6. And then now this is too high. Well, I mean, it still may be too low because we modded by a number, but so this is just very confusing. Why this is not right? Because the maximum k for a current left is the summation of all the. I don't get it. This should be. I mean, I don't know. But the what am I missing a base case? No, just left and k is equal to 0, right? Which we have here. K is less than 0 is here. So what is happening that is wrong about this? Like I could be. I mean, there should be. We don't fill up enough of the previous row. But looking at this array, we don't even need more than the previous. The previous row should be just. This is just k. I don't know. Let's see if that works. Oh, k plus 1 maybe. Oops. Because we don't really. Man, I'm really sloppy today. Okay, I mean, so that works now. You can see that it actually runs pretty fast even without the optimization. But it's still going to be too slow because it's. Oh, I think I tried to be too clever. I think, okay. So that's me being dumb, is that, well, not necessarily, but I would try to throw all the possible k's, but the thing to notice is that k can only go up to 1,000. So if k is equal to less than 1,000, then you don't have to worry about all the other ones. Like k could be up to n squared, but this k is less than n, and that's something that we should take advantage of. But I think I got carried away with the complexity analysis, which is why I have all these weirdness. But yeah, but this is actually right, except for that is n times k for obvious loop reasons times d, which is another n. Okay, so this is actually the solution. Not yet. The thing is that, okay, you notice this thing, so then why not, we can actually pre-calculate this, right? So let's actually change this back to 0 times k plus 1. I am dumb. Yeah. But yeah, now we just have a prefix sum, say, of this thing as well. And then after every, well, we could do prefix, this is true. And then now, we can do a for loop afterwards of the prefix array, right? So for we have prefix of left of current k increment by prefix of left of current k minus 1. So actually let's start this as 1, right? And then now in that recurrence, now that we have that here, that means that dp of is equal to is just equal to the prefix of left minus 1 current k. Whoops, why does this have so many thingies? Current k, right? I mean, I know that I wrote it in an awkward way, but hopefully this is oh, because I have to do it all over d, not over k. So now we have to convert the d to this thingy, right? But otherwise we're roughly almost done, pretty much, to be honest. I just am really bad at just really bad today. But you know, sometimes you have to grind it out and make these observations and things. Okay. So, but you can also see that I have or had all the tools to solve this. It's just, even then, sometimes it's tricky. So yeah. Okay, so d is equal to n minus left. So oh yeah, so then is equal to the sum of. Oh, I see. So what we want now is, again, and this is prefix sum, so the prefix of left minus 1 of current k minus prefix of left minus 1 current k minus max offset, which is d. Something like that, maybe? Maybe it's off by 1, but let's see if we get a reasonable answer. And of course this is, let's max of this and 0. Do I get a non-zero answer here? Just want to make sure that I have a big number. Okay, so maybe I'm missing something weird. The prefix for, okay, let's just say we do for 1, right? Don't need this. So we have okay, so if left is 1, then and k is 1, then this would be 0 1, which is 0, which is very awkward. Am I correct here? Let's look at that for loop again. So this goes from offset is 0 to offset is equal to d. This should be right, but we're also just am I doing the prefix wrong? Let's make these numbers smaller. And then oh, is this right? Yeah, I guess it should be right, but let's print the prefix away real quick. Yeah. Let's take it out. So the prefix array is just wrong, so that's why everything's wrong. Why is that? Because because we're always minus at least 0. So because my prefix array is off by 1 in that it doesn't have a 0 element. Okay. If k minus d is greater than 0, then we do this. Is that good enough? Well, this one may be 0 too, so that's why. No, that shouldn't be the case, should it be? Well, I have to fix my prefix array. I think that's why. For left is equal to 0. Now that I think about it, because I just have one, like for prefix sum array, this should all be 1 in the first row, and I am not doing that. So yeah. So for current k in range of k plus 1, prefix of 0 of current k. Okay, I mean this is better, but well, we filled the first row correctly. Now we have to fill out the second row, which is the hard part, I suppose. Well, I mean they're both hard, clearly, but dp. Oh, well, that's dumb. That's true. Plus dp of left plus current k. Okay, I mean, it's progress. We might even be right. It's just that we don't fill out n because one of our loops is wrong, maybe. Why is this loop wrong for this one? Do I have any weirdness? Huh? Of all the things to be wrong, I didn't expect this part to be wrong. Or maybe, like, why is all my answers correct? Well, not, I don't know about correct, but they give me reasonable answers, except for the last array. The last array. I don't even know if this is right, because this repeats twice. Dynamic programming is hard sometimes, even when you know what you're doing. I am sloppy, so maybe this is good practice. Need more sleep. I have a lot of excuses. Subscribe for more excuses. But why don't I fill this out? Is this fine? Does this? No, I'm not looking for the right answer. I'm just looking to see if it gives me an answer. Okay, so the subtraction is the issue, though it's not even giving me the right answer. No, so we need this -1 because this is a prefix thing. So we want to subtract it because we want to include this into the sum. So I'm off by 1 in the inclusion of the sum. Okay, that's why. That said, it's still wrong. Why are you wrong? Am I doing the prefix one incorrectly? Like, am I having an off by 1 here as well? The techniques are right, but this is very sad. Sag. Let me think about this for loop. Well, this 0 is wrong, right? Because do I not do it? It's okay. Maybe we just never fill out 0? No, I mean DP left of is equal to this. This should be 1. And then why do I get 0? This is definitely wrong, right? 3 and 0, or any prefix like 1 and 0 changes, it's always going to be 1. Am I off by 1 in a way somewhere? Is my prefix array wrong again? Oh, because current k, for some reason I did. Well, it's not some reason, it's because I have this thing, but we have to set up. Oops. Okay, I'm just wait like so. Yeah, I have all the things, but this is way sloppy. Let's do some big numbers and see. We actually have to make sure that our optimization is right. We have to do the mod math in more places, because the thing is that if you don't, and this is still going to be correct, but you may actually run into runtime issues because the numbers here may be too big. So we need to kind of consider that. Yeah, and I think this should be okay. Because basically you want to bound the calculation, at least in Python, without doing it. So yeah, okay. I mean, actually, it ends up being slower because we do a lot more mod. But actually, this only goes up to n squared, so I don't think we need it, because it does slow it down. Because these are all prefix sums, so usually with prefix sums, you only goes up to n squared-ish, maybe n cubed, but either way, it's bounded pretty. I don't know. All right, let's give it a submit, and then we'll see what happens. Hopefully, it doesn't give me time limit exceeded. Okay, cool. So this was a very long video. But you can kind of see my thought process as my breakdown problem. I hope you watch it on 2x or whatever, but because I just have a lot of silliness. But to be honest, but I think that is actually one of my annoying thing, is that like I think my patterns and strategies and stuff like that was okay, but I just have been really bad on implementation for whatever reason. As you can see, I had off by once in a couple of places. I have off by once here. I have off by 1 here, and that was a mess. So yeah, I don't know. But anyway, in terms of space and time, it should be, as you can see here, just there are 2 loops. This is n, this is k. So we have n times k time, and you have n times k n times k space. And of course, if you're well versed in dynamic programming, this is actually a straightforward thing to reduce this from O of n times k space to just O of k space. I'll leave it as an exercise for viewers at home, but this is basically the thing that I have. Yeah, I wish I kind of took a snapshot of the code that I have in between so I could kind of teach it in a different way. But hope this was good. Hope this was helpful. I spent way too long on this. Hope you enjoy it though. Anyway, it is Saturday. Happy weekend, and have a great weekend. Have a great next week. Hope you come back. Stay good. Stay healthy. to good mental health, and I will see you soon enough. Bye bye.